Okay. Can you see my slides, Marco?
Yes, I can see them now. Yes.
Perfect. All right. Thank you everyone for joining us. Today we will be talking about monitoring CO2 levels and also about indoor air quality. This session is very special because it is timely in the times we are living. This is why we have asked Marco, the founder of Connected Inventions, to join us today in this session. We will talk about indoor air quality and CO2 levels in the context of COVID. I will do a short introduction. And after that, Marco will talk to us about Connected Inventions, introduce his company, but also about very important subjects, such as why clean air matters, the device, the solution that's been used to allow you guys to do it through Sigfox, the connected air with CO2. And we will go through a 15 minutes Q&A session because I guess you guys will have a lot of questions. As a short introduction, I would like to talk about indoor air quality and CO2 levels in the context of COVID-19. This is a subject that is very present lately because we're living a new normality. We are being obliged and we have to live with the virus and prevent it from spreading, right? That means that at a social level, but also at a business level, we need to set up strong sanitary protocols. We need to disinfect, and we need also to know when we have to ventilate a room or an area. That has created new laws, new measures being taken. Government or local authorities, they are, for example, making mandatory the use of CO2 sensors. We have an example here in Spain, where the government of Mallorca has made it mandatory for restaurants to have a CO2 sensor before they can receive guests in them. Most importantly, in the context of Sigfox and Connected Inventions, we're here to prove you that IoT is here to support these digital needs, meaning that we need to be able to check, sometimes remotely, if we are in a secure area or if we are putting in danger the people that are using it. So through IoT, we're able to prevent this from happening, and we can use solutions such as the one we will introduce you today. Just a few guidelines for today's webinar. I would like to invite you to feel free to drop us any question you may have via the question box. I see that some people already used it, so please feel free to use it. And also, even if the webinar is going to be in English, you can write your questions in Spanish. We will translate it to Marco, and he will be able to answer you. In terms of prices, they will be shared with you in a separate email upon your request. So if you want to know it, just tell us in the question box or send us an email afterwards, and we'll be happy to share it with you. And as a last reminder, don't be shy and ask away. I will now give you the lead, Marco, and you can share the presentation yourself, okay? So it will be smoother.
Okay, just a second.
Making you presenter.
Okay.
You should be able to do it.
Perfect. Let me just... I'm sorry, but it's saying that it's failing the screen share. So do you have my presentation there? Can you show it?
Yes, I can share for you if you want, Marco.
Yeah, can you roll the slides and it seems
of course.
to be
perfect.
Constant struggle
Just give me a
with
second.
Perfect. Thank you so much. I'll just tell you when to switch slides.
Perfect.
While waiting, terrible sorry about the delay when I tried to come here. Big computer troubles, but good that it works now. So waiting for the screen and starting. Perfect. Thank you. So yes, my name is Markku Patronen and I come from Connected Inventions. We are owner of Sigfox Espanja and global part of global Sigfox ecosystem and specializing really on indoor air quality and indoor air quality IoT solutions. Can I have the next one? Here is where we come from. So yes, we are just like Sigfox Espanja. We are a Sigfox operator here in Finland and in Estonia. So we operate 2 networks. We also provide software services called Foxer IoT, and then Connected Inventions is our solution company, which has been developing, manufacturing ultra low cost, energy efficient IoT product sensors for 5 years now, and like stated, we are really specializing on indoor air quality devices. Can I have the next one? Thank you. Today we are quite global solution provider. So we actually been deploying our sensors and solutions in more than 45 countries, and then actually almost 300,000 devices already manufactured and deployed. And our mission is really to tackle the global issue of indoor air quality. We know that there are massive challenges in outdoor air quality and air quality, but indoor air quality, that's actually even more important because we spend so much time indoors. And of course now this COVID crisis has been a really kind of wake-up call for everyone, how important it is to monitor and see those issues in indoor air quality and real-time data. Can you put the next one? Our product portfolio consists 12 different hardware solutions for different purposes, and I mean, starting from indoor air quality, but also asset tracking, postal logs, and some industrial solutions. But when you put the next slide on, you'll see that most of it are actually tackling with the indoor air quality things. Temperature, humidity, CO2 level, which we are going to talk about today, but also small particle matters, which penetrates to people's lungs. So we provide that kind of monitors, volatile organic compounds, and pressure differences. So all kinds of small data parameters which really make the difference when measuring indoor air quality. Now, if you can show the next one. So why clean air matters? It's really a big thing for us. We inhale 20,000 times per day and 10,000 liters of air every day. So it's really vital thing for us. So in that sense, it's pretty essential to know what we are actually sucking in our lungs. Now, right now we have lots of researches, and it's very obvious that COVID-19 virus is spreading through the air. So that's the main cause of this disease. But there is of course more in indoor air quality because we spend so much time indoors, and there are all kinds of nasty things which are obviously invisible in buildings. COVID is big issue right now, but there are also other viruses. There are molds. There are volatile organic compounds, harmful gases which we don't know and breathe by accident, and it's costing us billions of euros or US dollars annually, and it actually kills people, millions of people yearly. Now the next slide. Different airborne particles are there. So biggest ones are obviously visible, but then the smallest ones are invisible and even super invisible. So going from the biggest ones to mold, bacteria, viruses are really small, and then DNA is super small. Depending on the size of these particles, they stay in the air for seconds, minutes, hours, or forever. And now when we look at the COVID and the viruses, those are ultrafine particles which can stay airborne basically permanently. Next slide. different particle sizes penetrate to your lungs in a different way. So some of those are actually are not, of course, going to your lungs, but the smallest ones, starting from the fine particles from 2.5 PM 2.5, they penetrate the lungs and they penetrate the bloodstream, and of course, ultrafine particles like viruses, like coronavirus, penetrates from the lungs to your bloodstream, and then we are in trouble. Next slide, please. So let's see if we can play this video. Please, can you play the video if we can see? So here is a video of I'm not quite sure if it goes. A person coughing, and this is actually a Japanese study which demonstrates how the small particles distribute and actually stay in the air for very long times. When person coughs or breathes or talks or sings, there are two types of particles. Basically, there are these bigger ones which don't stay up in the air. Social distancing is good enough to keep those away from our breathing, but then we have these really small aerosols which can actually stay up in the air for hours if the room or space is not ventilated. So basically, this is there are many of these demonstrations made in globally, which are clearly proving that these more aerosols are really big problem when we have a person carrying the virus in indoor space, room, restaurant, classroom, wherever, and the longer the person stays there, the more these aerosols are in the room. And of course, unfortunately, these aerosols and viruses cannot be detected as such from the air. So it's a big challenge, and that's the really challenge here. So can I have the next slide? So what can we do? Well, there is super simple way to measure the risk, because CO2, carbon dioxide, is basically in indoor air environment. It's the exhale air we produce when we breathe, when we speak, when we sing, or basically whenever we open our mouth. And several governmental institutions have stated it loud and clear that the threshold of CO2 level, which is the risk level, is 800 to 1000 ppm. So on this slide, you see the kind of general classification of indoor air quality. It's excellent. Fresh air, outdoor air is 400 ppm. Nowadays, it's actually growing slowly every year because of global emissions. But from 400 to 600, air is really fresh and basically safe. It doesn't contain any big amounts of people's exhale air. But when we go towards 1000 ppm, things actually change. So previously, the threshold has been 1200 ppm. So that's the kind of threshold stated as a kind of sort of bad, thick air in indoor. And then someone should do something, increase the ventilation or open the windows. Otherwise, people are, the kind of typical symptoms are you getting tired, you lose the kind of concentration on whatever is going on. And then things go really bad from 1600 to 2000 ppm, and then you really kind of starting feeling the nausea and lack of concentration. But with COVID virus, the threshold is actually a little bit lower. It's in 1000 or even 800 ppm. So that's the level of CO2 concentration to watch. Now, can you put the next slide. So it was actually a demonstration, an article in El País newspaper a few months ago, but it's actually a fantastic illustration of how the risk mitigates. This is a classroom situation where, in this case, the teacher is carrying the virus and is the one who is actually speaking in the classroom. In the next slide, we see what happens if no masks are used and no ventilation is taken care of. So this is the riskiest scenario: closed classroom, not a good ventilation, no one is using masks. Of course, we are using now masks because those are mandatory. And in the next slide, you see the effect of using the mask. So it improves the situation, especially when the teacher is using the mask, because she's, in this case, in this scenario now, spreading the virus as a patient. But it still penetrates because of these small, nasty aerosols. On the next slide, we can see the modeling if ventilation is taken care of. So ventilation is super important, and of course, reducing the time used in those spaces. But the trick to know when to use the ventilation, when open the windows, and what is the real situation, because this whole thing is invisible. CO2 monitoring is basically the only way to measure the risk indoor space. That's why it's so important, because it makes the invisible risk actually visible. Of course, no one can tell if someone is carrying the virus, but we can still prevent bad things to happen. And on the lower right corner of this slide, there is an example of how to illustrate this situation. So it's actually a real life deployment made by one of our Irish partner. Simple mobile phone application showing either green, orange, or red screen to teacher or to janitor of the classroom, which tells that everything is fine. It's under 800, 1000 ppm. If it goes over 1000 ppm, there is an orange warning sign which tells someone to open the window, open the doors, ventilate the room, maybe take a break. And when it's red, something should really be done. So simple as that, and that's fantastic preventive measure in this COVID crisis. Now, if I can have the next slide. Most of the cases we are monitoring. It's hard to represent the data because it's quite sensitive data of our customers. But here's just one example, actually quite recent, from last December, from GITEX 2020 Expo, which actually took place physically. And here are the results of CO2 monitoring from the Expo. So it's a huge trade show. But it was a little bit smaller last December because of the global situation. But anyway, it took place in Dubai World Trade Center, which is a huge expo hall. One could sort of expect that in these kind of places, someone is taking care of the ventilation. But we monitored the CO2 concentrations in the expo and discovered these kind of results that actually over one expo day. So here are the measurements from the 5 days of expo. First day was rather okay, but the second day, starting from the afternoon, it actually started to break 1,800 ppm readings, and it's not good. This is a warning sign, and these results have been delivered to Dubai World Trade Center people to really see the real life situation of CO2 concentrations in the expo hall in these type of events. And I can only imagine what would be the situation if it would be as big as previous years when there was no COVID and expo halls were packed with the people. So this is something they need to consider, and I'm really hoping that they do something for the ventilation of these expo halls. Can I see the next slide, please? So how can we help? We can measure indoor air quality. We can't prevent viruses. We can't prevent these coming. There has been viruses before COVID. Of course, this is a really catastrophic situation right now, but there has been viruses and there will be viruses and there will be all kinds of diseases. But we can make a difference. We can reduce them to spread by monitoring our indoor air quality. Schools, classrooms, apartments, office buildings, warehouses, basically all indoor facilities we can really monitor, and then we can act. Now, next slide, please. So here is our solution. We manufacture, provide, and deliver globally really low-cost, ultra battery efficient CO2 monitor, which measures CO2, temperature, humidity. Battery lifetime is 5 years if you run it with a 30 minutes measurement and sending interval. Of course, it can be changed. It's compatible with any IoT platform, so really flexible solution. And it's been widely deployed, and here is the device if you see it on my hand. So really neutral looking device, super reliable and really accurate. So we use real CO2 sensors in our devices, not like something which provides guesstimation of equivalent. It's real CO2, and the accuracy, it's 10 to 40 ppm, which is really good for these purposes. Now the next slide. So beyond the current COVID crisis, so hopefully we will get better situation soon, and we will tackle this disease by vaccinations and preventive measurements. When it's over, there are of course other benefits than fighting against COVID. When you monitor CO2 concentrations, whether it's a classroom or office or even your home apartment, because there are other diseases, other bacteria, flus, viruses. So by measuring and by preventive maintenance, you can actually have less sick leaves. And we have a really interesting classroom case from Ireland, where our partner deployed these sensors in the schools. So first of all, of course, it provided safer teaching and learning environment for teachers and kids who were in the school right now. But they also discovered that sick leaves of the teachers came down by big time. So much less sick leaves of the teachers by ordinary flus and other diseases, which is a cost saving for the school. And the principal was really surprised and happy to see that, okay, we can actually have results beyond the COVID crisis. Monitoring and then providing fresh air, classrooms, offices, it enables people to focus better. We lose our concentration when the air is thick. So that's really important and shouldn't be neglected at the moment. And of course, we can operate the ventilation by way more efficient way by monitoring indoor air quality. So maybe we can reduce ventilation when there is no people inside the rooms, and then we can put it on the max when really needed. and it gives visibility to invisible things, which provide happier users of the spaces, and people feel more safe, whether it's work or school or public place. Now, can I have the next slide? Thank you. So to summarize a couple of things, COVID-19, it spreads through the air when CO2 levels are high. There's no question about that one. We know there is a problem in the indoor air quality today. There are actually multiple problems, and it's really hard to tackle those problems without knowing what's the exact situation. We do have sensors, we have technology, it's there, it's easy to use, and it's really available. We have a big track record of deploying these solutions. We actually deployed and delivered these sensors even before COVID crisis, but of course this COVID crisis has sort of really expanded the whole market. And of course we are here to help with any of you who would be keen on deploying these sensors or doing a pilot or seeing how these could be used. Now the next slide. Basically, we have two options, like in most of the cases in the life. So we can close our eyes and cross our fingers and hope the best, but we like to say that hope is not a strategy. It really is not. When you can do actually something. So you can use technology which is available. You can measure, then you know you can act, you can fix problems, and of course you can also show the data and create safe spaces for the users of spaces, which in our opinion will be part of the new normal world once we get over the most severe situation, which is obviously right now. But the awareness of the importance of indoor air quality is quickly growing, and I'm betting that more and more people are actually expecting the owners of premises, houses, spaces, classrooms to provide this information. That's my presentation. I would like to thank you, and maybe questions, comments, either in English or Spanish. Unfortunately, my Spanish is not really good, so I can only answer in English.
Thank you, Marco. As said right now by Marco, we invite you to ask away your questions if you have any. Now is the time to ask. This has been a lot of information, but really valuable information about the use of CO2 sensors. Let me check, Marco, and see if we have any questions. Okay, Diane is asking you how many devices you would recommend per square meters.
That's really good question, and we've been asked a lot about that one. So it of course it depends on the space, how big is it, or is it kind of how complex place it is, how many people are there. But typically, for example, in the open office environment, we recommend basically 2 sensors per 100 square meters of CO2 device. If there is more people, maybe 3 per 100 square meters. 1 per each classroom, 1 per each meeting room. If it's a big auditorium or big, super big classroom, again, maybe 100 square meters, then 2 devices. An important thing is of course install those devices to a height of level of where people are breathing the air, so it gives a good picture of what is happening on the level where people are actually breathing.
Very well, thank you, Marco. Let me check if there are any other questions. We have a question here from Wolfram asking if you are offering devices only, or are you selling an application, or do you sell it as a service, or any language support? This is many questions. Sorry. Let's start by, are you offering devices only?
We offer devices only, but we also offer devices with platform. So basically, we give our customers and partners freedom to decide whether they want to use something existing, whether they want to develop something on their own, or whether they want a full solution. So we are completely flexible.
Right. We have a question from Pablo. Do temperature and humidity affect the spread of COVID?
Yes. Temperature, not that we know, because the virus can survive in different temperatures very well, unfortunately. Of course, sun is killing, and really the heat is killing the virus. But we know that the humidity is a big factor, and that's really good question, because humidity it's not affecting on the virus, but it's affecting on the aerosols. So if the air is dry, the aerosols stay in the air much longer. But if the air is humid, and the threshold here is 40% relative humidity level, so that's the threshold. If it's more than 40%, air is so humid that even the aerosols actually go down faster. But if it's dry or super dry air, like it is here in Finland, for example, right now, because we have to heat our houses, that's causing extra issues. So that's why it's also important to understand the relative humidity.
We have another question from Guillermo. He's asking if we could explain what type of technology or which technology is being used to connect the sensors and the platform that receive the data. I know the answer, but I will let you answer it.
Yeah, so we are using Sigfox Global Connectivity technology, which is by far the best and the most simple way to connect these devices directly to network, and then the network is super robust, and it's really made for this kind of small data, and it of course enables us to make these devices so energy efficient that they can last years without any kind of battery changes.
Diane is asking another question. It's true that we didn't see it. She's asking if there is any application to monitor the CO2 on our mobiles, for example, for a teacher or a store manager. As you were saying for the classroom before, right? You were showing the 3 screens.
Yeah. So several of our partners have made these kind of mobile apps. We have made a tablet solution by ourselves. So we have a tablet screen showing the real life data of these sensors, because these sensors they don't have a screen.
Right. Let's see if anyone has another question. Bring a message to all participants to encourage them to ask. We do have one, I think. No, we don't. Okay, Guillermo says that it's not quite clear for him. He's an architect and he would like to know if it works through Wi-Fi or radio. I can help you on that one if you want, Marco. Guillermo, para contestarte en español, la tecnología es Sigfox, es decir, que el protocolo de comunicación que se usa es la infraestructura de Sigfox. No es a través de Wi-Fi, es a través de radio, en este caso, nuestra tecnología. Y eso es lo que permite mandar la información del sensor hasta la plataforma que luego te permite pues, monitorizar la concentración de CO2 y visualizar la información. Espero haberte ayudado a entender un poquito más este aspecto de la solución. Okay, we do have a question from Gabriel Marcu. He's asking if intervals of 30 minutes are not insufficient.
It depends on the case. The intervals can be anything between 10 minutes to 2 hours. So that's but based on our customer deployments, it's either, I mean, 30 minutes is mostly used, because that actually gives a quite good picture of the CO2 concentrations, and it maximizes the battery life time. But we have cases, I mean, for example, in classrooms where it's been set up for 10 minutes. So up to the deployment.
Okay, thank you. We have a question from Cornell. He's asking, or he or she is asking, if we can download the historical data if there is no Sigfox connectivity.
At the moment, not from these devices, so they don't log the data. So there is no memory in these devices. We keep it simple, and that's why it's super important, of course, to make sure that there is a connectivity when you install these devices. But there is no, I can maybe there is no packet loss. There is no, these devices are super robust, so they don't miss the messages. So if the coverage is there, these devices work, and there's no messages lost.
All right, let's do 5 more minutes. If we get more questions, please ask away. All right, Marco, looks like we are done with the Q&A session. We don't have any more questions. Anyways, if any of you would have more questions, we will send you a thank you email with our contacts, mine and Marcus. So you can always drop us an email, ask your questions, ask any information about the solution. As I said before, the pricing, or as you were asking before, Gabriel, to ensure that there is coverage of Sigfox, since the network is already deployed. We can assist you and know how it works, okay? That leaves me with the thank you phrase. Thanks everyone for joining today. Thank you, Marku, for being here, even though it's remotely. We've made it work. And that's what you could do with a CO2 sensor. You don't need to be there to be able to monitor it. So that's the essence of this solution. Thank you.
Excellent. Thank you, everyone. Stay safe and wear masks and start monitoring indoor air quality, and let's make the difference.
Thank you.